Okay, continuing with the review for the test, we're going to talk about rounding. Um, First of all, we'll look at decimal places. Remember that there's the decimal places on the left side of the decimal point, which are pretty easy. The ones, the tens, the hundreds, and the thousands. Okay. On the right side of the decimal point, it's a little bit more challenging because it does not start with the ones, it starts with the tenths. Okay, so the first one is already tenths, and the second one is the hundredths, and the third one is the thousands. Okay, so remember there's only one ones, or there's only one units place, and that is right here to the left of the decimal point. Once you go into the decimals, your first number is already representing 1/10 of a unit. Okay, there's only one unit. To the left starts tens, thousands, or tens, hundreds, and thousands, and to the right there is tenths, hundredths, and thousands, and 10,000s. Okay, so if somebody says let's round to the nearest thousandth, then you just count units, units, tenths, hundreds, thousands. So this would be your last number, and then you would use the next number, which is 4, to determine whether or not this last number is going to stay the same or go up. And that's what we're going to talk about rounding now. Okay. Before we talk about rounding, we're just going to talk about significant figures really quick. I'm showing you 3 numbers here, and we're going to figure out how many significant figures in each. This is kind of a non-traditional number where you have a bunch of zeros at the beginning, just for the sake of argument. Okay, maybe something like this might come out of a computer. Basically, these left zeros here have no meaning. Okay, so you can always ignore left zeros. Okay, right zeros are the challenge. Sometimes right zeros you ignore, and sometimes you don't. So we're going to figure out when you can and when you can't. Okay, so in this, the rule basically is this. When you want to count significant figures, figure out where the leftmost non-zero digit is, that would be that one, and then figure out where the rightmost non-zero digit is, that would be that one. Everything in between the two is going to be a significant figure for sure. Okay? And now the only question is, what about the zeros on the right? And then we have to figure that out in each case. Okay? In this case, they are significant figures. And the reason why they are is because there is no reason to put these here for placeholding purposes. Now if you look at the zeros here in the middle, why are those zeros here? Well, if those zeros weren't there, then the 6 and the 7 wouldn't stay in the right place. Okay, they're placeholders. The zeros here on the right, they are not placeholders. So if they are there, that means that they were actually measured, and the person measured a 0 there. It just happened to be a 0. It wasn't a 9, it wasn't a 1, it happened to be a 0, so he puts a 0 there. Okay? So when you have zeros on the right side of the decimal point at the end, those are significant figures. Okay? If you're like saying, why are those zeros there? And the answer is they're not placeholders. That means they're significant. Okay? So let's go to the next one. It looks like kind of the same number, but it's a little bit shorter. Now remember, the left zeros are just nonsense. Okay? Those have no purpose. Okay? And then we're going to look, and the leftmost non-zero is that one. The rightmost non-zero is that one. In between, we know these are all going to be significant figures. Okay? So the question is, what about these 3 zeros here? Okay? And if we look at these zeros, why are these zeros here? Well, this 0 is kind of a placeholder, right? It keeps the 1, 2, 3, 0, 4, 5 in the right place. But these zeros here on the right side of the decimal point, those are not placeholders. So why are they there? Well, they're there because they actually got measured, and if they actually got measured, they're significant also. Okay? So in the first case, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 significant figures, I think. We're counting from the 1 here to the last 0. Okay? In the second case, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 significant figures. Okay? And in the last case here, how many do we have? Well, the zeros at the beginning we ignore. First non-zero, last non-zero, everything in between is a significant figure. So the question is, what about this one? That last 0. Why is that there? Well, it's there for placeholding, right? Because if it didn't have it there, then the 1, 2, 3, 0, 4, 5 is not going to be in the right place. So this is a placeholder. If it's a placeholder, it probably wasn't measured. Okay? We don't know for sure, but the rule is, if it's a placeholder, you don't consider it a significant figure. So in this case, we have 1, 2, 3, 4, 5, 6. 6 significant figures for that number. Okay? So if the 0 is on the left side of the decimal point, that means that, and it's the ending the number, then that means it's not significant. Okay, it's just a placeholder. Now let's do a rounding problem here. Round to the nearest 10. So the last number after you round it is going to be the 5. Okay, so what's going to tell you if the 5 is going to stay the same or go to a 6? The next number, which is a 6. Okay, so if you round this one, the 6 is above 5, so we know that that's going to make the 5 go up. So the resulting number is going to be 3, 1, 6, 0. Okay? Now these next problems, we're going to round to the nearest whole number. Okay? So 23.51. So the last number we're going to have after the rounding is going to be the 3. Okay? And what's going to tell us whether the 3 stays the same or goes to the next number? The 5. So if it's a 5, that means it's going to make the 3 go up, right? And when you look at the next number, you're only going to look at the next number, the 5. You're not going to look at the next number, the 1. Okay, just ignore that 1. So 23.5 is going to be a 24, right? When it's the nearest whole number. Okay. Now what about 23.49? In this case, do not make the mistake of looking at the 9 and thinking that makes the 4 go up to a 5, because we are just rounding to the nearest whole number, which is the last number is a 3. So we're just trying to determine if the 3 stays a 3 or if it goes up to a 4. What determines whether that stays a 3 or goes up to a 4 is only the next number, the 4. The 9 you're not going to look at. Okay? So in this case, the 4 is there. Is the 4 above 5? No, it's not. So the 3 is going to stay the same. So rounding to the nearest whole number, it's going to be a 23. Okay? If you say 23.49, the 9 makes the 4 go to a 5, 23.5 goes to 24, that is a big mistake. Okay? You do not consider the 9 when you do this rounding. Okay. Now we're going to do these last problems here. We're going to round to the nearest 100. Okay? So, where is the hundredths? So if you remember, at the beginning we said the only units or ones is here. Okay? So that's the ones. So the tenths is here. The hundredths is here. Etc. Okay? This is the thousands. Okay, so the hundredths is here. This is going to be the last number after you round it. Okay? So what's going to determine whether this 2 stays a 2 or it goes up to 3? The 4 is. Okay? So the 4 is less than 5. Ignore that 8. I know you want to look at that 8, but ignore it. Just look at the 4. The 4 tells you that the 2 is going to stay a 2. Okay, so after you round it's going to be 43.32. Okay, and the rest of it you ignore. You do not need to put a 0 after that. Okay, in fact, if you do, it's kind of wrong. Okay, when you round, the last number should be the number they tell you round to, which is the nearest hundredths. That should be the last number you round, and that's the last number that should be there. Okay, now let's round the same number, 43.3248. We're going to round it to 3 decimal places, okay? So how many decimal places do we want? We want 3. We want that number. We want that number. We want that number. We do not want the 8, okay? But the 8 is going to influence what we do with the 4. What are we going to do with the 4? The 4 is going to stay the same, or it's going to go up to 5? It's going to go up to a 5 because the 8 is greater than 5, okay? 43.32 is going to be a 5, okay? Now we have 3 decimal places here, okay? Now we're going to round to 3 significant figures, okay? So we're going to have 43.3248. 3 significant figures would be there, there, and there. When we count significant figures, we always need to start with the leftmost, okay? So we have 3 significant figures. We want the number to be either 43.3 or 43.4. What's going to determine whether it's going to be 0.3 or 0.4? It's going to be this number here. And 2 is less than 5, so the 3 is not going to change. Okay? And the last thing we just need to be careful about when you do rounding, and let's say you have like 49.9, and let's say we're going to round to the nearest whole number, okay? So this is going to be the number that we're figuring out if it's going to be 9 or the next number, 9 or 0, okay? And this is the number we look at to figure that out. 9 is way above 5, so it's going to make the 9 go up to 0, okay? Now if the 9 goes up to 0, we of course can't keep the 4 as a 4. It has to go to a 5, okay? So that's something to be careful about in rounding, okay? So I think the trickiest thing that some people have made mistakes with is, for example, when they look at that one and they want to round to this 2, they want to round it to 2 or 3, they make the mistake of looking at the second digit after. You should only look at the next digit, which is a 4. You should not look at the 8. Okay, ignore the 8. Alright? Thank you.